All right. Hello, everybody. This is Mr. Ingram here. So, for today, I've decided to make a part 2 to the IXL video because in the other one it doesn't kind of go into a different type of problem. All right. So, this type of problem, the difference is, if you'll notice, at the z equals x plus 17, in the past it would just give you a value, but in this case it gives you a variable with an added constant to it. So sometimes it'll give you a variable, sometimes it'll give you like a expression like this. Okay, so I'm going to kind of show you how to work through these types of problems using substitution. So anyway, I'm going to do a couple of these and then we will call it a day. Okay, so I'll be switching off between here and my the IXL. I just want to make sure, confirm that I have the correct one, that I wrote it down correctly. Okay, all right. So here we're given z equals that. So what we need to do is, for z going forward, we need to plug in this into z for both equations. Okay. So for this one, we're going to take up a little bit more board space. So let's see. I'm going to just right here. So we have negative 6x plus 2y, but instead of z, we're going to write minus 3 times x plus 17 equals 22. Okay, so what we need to do is distribute our 3 and then combine like terms. Okay. So we have negative 6x plus 2y minus 3x plus negative 3 times 17 is negative 51 equals 22. Okay, so from here we need to combine like terms. That becomes negative 9x, and this becomes 2 plus 2y. And then I'm going to add 51 to both sides. And what that should give us is 22 plus 51. 2 plus is 73. Okay? All right. So that's the first one. Okay, and then the next one, what we need to do is do the same thing. So here we have 3x minus 6y plus 2 times, but instead of z, we're going to write x plus 17 equals 13. Okay, and when we do that, we have 3x minus 6y plus 2x plus 34 equals 13. Okay. All right. We have here 5x minus 6y. And then if we subtract 34, we have negative 21. Okay. So here we have 5x minus 6y equals negative 21, and then in the other end, we have negative 9x plus 2y. Okay, so I'm going to write that down on this whiteboard to symbolize step 2, that we have moved on to step 2. Okay. So from here, what we should have is a system of 2 variable equations. Okay. All right. So from here, what we can do is use elimination or substitution to solve. Okay. I'm going to use elimination, and I'm going to solve the. I'm going to eliminate y. Okay. So to do that, I need to multiply this by 3 because I want this to this 2 to become a positive 6. Okay. So what this should become is negative 27. Plus 6y equals 73 times 3. I'm going to do that on my phone just to save time and be accurate. Times 3 equals 219. All right, so then we go from here. So that cancels. That becomes negative 22x. And this becomes, let's see, 219 minus 21, which equals 198. Okay, so then we're going to divide this by negative 22, and we get 9. Okay, So x equals negative 9. Okay, so that's x. All right, so then what we can do is plug this back in to either of these equations to get y. I'm going to do the bottom one. So we have 5x, so negative 9 minus 6y equals negative 21. So that equals negative 45 minus 6y equals negative, 21, not 12. That would be a problem. So we're going to add 45 to both sides. Negative 21 plus 45. So that means we get negative 6y equals what is 45 divided by negative, or 45 minus 21? Why is my mind blanking? Oh, 24. Yeah, positive 24 divided by negative 6 divided by negative 6, and we get y equals negative 4. Okay, so we have y equals negative x. Well, x equals negative 9. Sorry, y equals negative 4. Okay, so then to find z, we need to plug it in back into our original equations. We could plug it in here, but I want to plug it into one of these two, just so that I know that y is right as well. Okay. Or I guess what we could do is we could let's put it into one of those two. Okay, so I'm going to erase all of this stuff here. Okay, and what we should have right here is, what did we get? We have x, I'm going to write this down, x equals negative 9, and y equals negative 4. Okay, so what we need to do is plug either of these into both of those equations just to check. Okay, so we have negative 6 times negative 9. All right. And then we have plus 2 times negative 4 minus 3z equals 22. Okay, so that should be 54 minus 8 minus 3z equals 22. That gives us 46 minus 3z equals 22. Minus 46 minus 46. And we get negative 3z equals negative 24. Divided by negative 3, divided by negative 3, and we get z equals 8. Okay, let's see if those work for the other two. So if we do it up here, we have negative 9 plus 17 equals 8. So that's a smiley face. Okay, we did it for this one, so we know that works. Okay, and then here what we should have is negative 9 times 3 is negative 27. Plus 24 and plus 16. Okay, so 24 plus 16 is 40, minus 27 equals 13. So that also works as well. Okay, so the answer for this one is as follows. I'm going to switch back to the IXL. Is negative 9, negative 4, and positive 8. Okay? Alright, so let's not do that one. I'm going to do one more just to start, just to show how to get to where we need to get to. Okay? So, for a problem like this, I'm just going to kind of get it started and then I'll kind of cut this off. So we have 4x minus 2z, and then we have negative x plus 2y minus 4z equals negative 23. Okay, and then we have negative 5x plus 4y minus z. Okay? Alright, so I have that written down. So I'm just going to show you how to get to where we need to start. Alright, so what we do is we just plug this into y for both of them. Okay, so let's do the first one. So we have negative x plus 2y. But instead of y, we're going to write 4x minus 2z. Okay, distribute our 2. Minus 4z equals negative 23. All right, we have negative x plus 8x minus 4z, and then minus 4z again equals negative 23. So then from here we just combine like terms. So that becomes 7x, and that becomes negative 8z, and that equals negative 23. Okay, so that's the first part, all right, of the equation. And then for the other part, let's see, I'm going to write that here we have y equals 4x minus 2z, and then the other one was negative 5x plus 4y minus z equals negative 29. Okay. All right, so from here, what we're looking for is another equation similar to this, where we have xy and then equals a number. So what we do is we plug that into here, so we have negative 5x plus 4 times 4x minus 2z minus z equals negative 29. Okay, so from here what we do is distribute. So we have negative 5x plus 16x minus 8z minus z equals negative 29. Okay, so from here we have, if we combine like terms, we should have 11x, and then that becomes negative 9z equals negative 29. Okay, so then what we would do is then write down here 7x minus 8z equals negative 23. Okay, and going forward, what you would have to do is I would use elimination, and you're going to have to multiply both of these equations by something. So anyway, I hope that was helpful in showing you what you need to do when it's a variable that you're given instead of a value. Okay, thank you. Have a good day.